Hello everyone, welcome back to my YouTube channel. My name is Srishti. I'm in my fourth semester studying in Sri Venkateshwara College of Engineering in the Department of Computer Science and Engineering. Today I bring forth a video on the subject analysis and design of algorithm. The topic of today's subject is sequential search. The contents of today's video is brute force approach, introduction, key characteristics, pseudocode of sequential search, how sequential search works, example of sequential search, programming in C, example of sequential search in C, advantages and disadvantages, practical applications and differences of sequential search and binary search, and conclusion. Now let's learn what brute force approach is. Brute force approach is nothing but generating all testing and all possible solutions until the correct one is found. It follows each and every step to get a proper solution. Let's see. In computer science, brute force approach refers to a straightforward approach to problem solving, directly addressing the problem's possible solutions without applying any strategic logic or established algorithm, generating and testing all possible solutions until the correct one is found. There are many types which can be used in brute force approach. The four types which we learn in our semester are selection sort, bubble sort, sequential search, and pattern matching. And the one which we'll study in this video is sequential search. Introduction to sequential search. Sequential search, also known as linear search, is a basic and straightforward search algorithm. It involves checking each element of an array or list one by one in a sequential manner until the desired element or the target is found or the end of the array list is reached. Let's learn some key characteristics of sequential search. First one, it is simple and initiative. Second one, unsorted data. And third one is linear time complexity. First one, simple and initiative. The algorithm is easy to understand and implement, making it a good starting point for learning search algorithms. Unsorted data. Sequential search does not require the array or list to be sorted. It works equally well on unsorted data. Linear time complexity. The time taken to search for an element increases linearly with the size of an array or list, denoted as O of n, where n is the number of elements. Let's learn the pseudocode. Function. Function here refers to the function name, sequential search, array, comma, size, comma, k. Here array is the array list, size includes the size of the array, and k is the key to be found. Set I is equals to 0, while I is smaller than size. If array of I is equals to k, return I. And if set I is equals to I plus 1, and while return I minus 1 end function. This is the pseudocode for sequential search. Here, there is a function known as sequential search which contains the array, the size of the array, and the k, which is the element to be found. I is set to 0, and while solving the sequential search, we should always make sure that the I or 0 is always smaller than the size of the array. For example, let the size of the array be 5. We should make sure that I is always smaller than 5. If array of I is equals to k, in case you find, for example, if you find the first element to be the key element, you can use this function and return the first element and tell that the element is found and end the if statement and the while statement. In case it is not the first element, which is the key element, you increase the value of I by 1. And here I becomes 1 and the while statement is closed. If only if the size of I is greater than the size of the array. If it is not, it keeps repeating the same cycle between the while. And in case the element is not found, it returns minus 1, that is, the element is not found and the function is ended. Now let's move on to how sequential search works in a step-by-step process. It starts at the first element of the array, compare the target value with the correct element. If they match, they return the index of the current element. If they do not match, they move on to the next element. This repeats steps 2 to 4 until the element is found. That is, from here to here, the steps keep on repeating until the element is found or the array ends. Let's look at an example. Let us consider an array containing the elements 5, 4, 3, 2, 1, and the key element to be found is 3. And first, as we see through the pseudocode, sequential search array size is 5 and element to be found is 3. And we set I is equals to 0. We make sure that I is smaller than 5. That is, since 0 is smaller than 5, it is true. And next is we have to make sure if the array of I is equals to k. K is 3. Array of 0 is equals to k. 5 is equals to k. Since the element present in A of 0 is not equal to 3, that is 5 is not equal to 3, it becomes false. Therefore, the value of I is incremented by 1. Now the value of I becomes 1. That is I is equals to I plus 1. That is 0. I is equals to 0 plus 1, which becomes 1. So in the second pass, the I value is 1. Since I is 1 and 1 is smaller than the size of the array, that is 5, it continues the while statement. Next, it checks the if statement. If array of I is equals to k, that is array of 1, the element of 1 is equal to 3. Since array of one element is 4, the value of array of 1 is 4. 4 equal to 3. Since 4 is not equal to 3, it becomes false. Therefore, the I value is incremented. And now the I value becomes 2. Next, now it does the same thing again. It checks if the I is smaller than the size of the array. Since 2 is smaller than the size of the array, that is 5, it moves on to the if statement. It checks if the array of 2 is equal to k. Since 3 is equal to 3, the statement becomes true. It comes out of the end if statement and the while statement, and but does not return the value -1 but ends the function, therefore telling that element 3 or value 3 is found in this particular position array 2 and is present in the array. Therefore, the key element is found this way through sequential search by searching each and every element once. Now let's see the C program of sequential search. This is the C program of sequential search. Here, as you can see, I have used the for loop. You can even use the while loop. And the example which I have taken is different from the example which I have explained in the example. It is a very simple program and easy to understand. Here is another walkthrough of the sequential search. This is the algorithm of the previous program, that is the C program of sequential search. You can see this. The array used here is 42713 and the target is 7. First, we compare 7 with 4. So the first element of the array, since it is not same, it skips or it increments the value, and next it is compared with the value or second value of the element, that is 2. Since 7 is not equal to 2, it again increments the value. Next, it increments the value to 3. And now here you can see that since 7 is equal to 7, match is found at index 2. Now let's learn some advantages and disadvantages of sequential search. First one is simplicity. It is easy to understand and implement. It does not require any sorting. No sorting is required. It works on unsorted arrays too, compared to bubble sort. Versatility. It can be used on arrays or of any data type. That means you can use float or int or double, anything. Disadvantages of sequential search are inefficiency. It is not efficient for large arrays. In case the array includes more than 20 values, it takes a lot of time. It has high time complexity. Linear time complexity can be slow for big data sets. Now let's learn the practical applications when they use sequential search. Small or unsorted arrays, situations where array elements are frequently changed. Simple search operation where efficiency is not a priority. Now let's learn the difference between sequential search and binary search. Time complexity, O to O of n, O of log n. It only elements one element from search per comparison. It elements half of the array element of each comparison. As n number of elements get very large, sequential search does not do the work. As number of elements get very large, binary search has to do little work than sequential search. Has to search element I comma I plus 1 I plus 2. Has to search element n divided by 2 comma n divided by 4 two elements. Doesn't require element to be sorted, requires element to be sorted. Easy to program but takes too much time. Easy to program and execution time is faster. Conclusion. Sequential search is a straightforward search method that is effective for small or unsorted arrays, but can be inefficient for large data sets. Despite its simplicity, understanding sequential search is fundamental to grasping more complex and search algorithms. Thank you for watching this video. I hope you liked it. Please do like, share, and subscribe.